Thank you very much. Okay, first of all, thank you for inviting me, Vincent and Sophie. I'm very honored that I'm allowed to share my research here, and well, I'm very much looking forward to it. This was a project that I did with Dr. Ivan Manjuli, Riesthuis Bogart, and Henry, who is here as well, which was recently published in New Ideas in Psychology, and is called The Impact of Fabrication of Recognition Memory, an Experimental Study. I'll first give a short background view. If there's anything that is unclear, please feel free to stop me, and I would love to explain more. But okay, let's get into it. When we talk about false memories, we often talk about, broadly speaking, two types of false memories. Oftentimes, this is called a spontaneous false memory, the one form of it, and that is something that is elicited without any external pressure or suggestive information from other people, but comes up spontaneously, as it says in the word itself. And oftentimes, this is studied as follows through the DRM paradigm, wherein participants are instructed to study the words symphony, sound, piano, radio, sing, orchestra, jazz, and note. And then afterwards are asked to recall or recognize which words they remember. What is often found is that they also remember the word music, which was actually never presented, but was elicited spontaneously, and that's why we call it a spontaneous false memory. A second type of false memory is also called a suggestion-induced false memory, and this is what happens when participants, for example, see slide A, afterwards receive suggestive questioning that suggests that the car stopped in front of a yield sign instead of a stop sign. Then afterwards they are presented with both pictures, and what happens sometimes is that people indeed start to misremember that they saw the yield sign instead of the stop sign. In this case, the false memory was elicited through external misinformation. Someone provided some misinformation and then people incorporate this. However, in our research, we wonder what happens when people get misinformation that they generated internally. So this is different from some spontaneous false memory, which arises completely spontaneously, and also from external misinformation, but really when they provide it themselves. So for example, when they are lying. And one of the first studies that examined such a thing we see forced confabulation as a type of lie because, can you guys still hear me or not?
Now
okay.
we can.
Oh, apologies. Okay. And we see forced confabulation as a type of lie because, well, I'll first explain what it is. In these types of studies, participants are instructed to watch a video, and afterwards they are interviewed about this video and are asked questions about details that were actually presented, also known as answerable questions, but also about details that were not presented, aka unanswerable questions. Before the interview starts, some participants are informed that they have to answer all questions even when they are uncertain. So this means that they are forced to give an answer to unanswerable questions. And then there's a control group who is told to simply provide an honest account of what happened. We see this as a type of lie because the participants know oftentimes that there is no right answer to this because they very much resist answering these questions, but eventually do provide an answer which they know the interviewer or they know to be false. So they provide information that is wrong. What they do afterwards is that a week later, they get another memory task and they are asked to give an honest account. They can all say when they don't know an answer, etc., just like as in the control group in the first session. And what do they find? They find that people actually form false memories for these fabrications. So when they provide an answer to an unanswerable question, they later on misremember this as part of what they truly saw in the video. Now, I've got some nice and exciting news because we just recently finished a meta-analysis of this forced confabulation effect. And we indeed found that across studies, there is a forced confabulation effect. That is, participants create false memories for their fabrications. I would love to present this at some other time because there are some interesting moderator variables that moderate this effect, but it does show that this is a true effect. And this will hopefully soon be published, because this was a stage 1 registered report at Memory. So we're waiting to see if it gets accepted as a stage 2. But we were wondering in this particular study whether this forced confabulation effect might also stimulate spontaneous false memories, so the ones that arise completely spontaneously. And that is, there are some theories, such as the associative activation theory, which is mainly based on spreading activation, that it might indeed lead to more spontaneous false memory formation. I will explain more in detail. The associative activation theory, there's a lot of information, but okay. Kind of says that, for example, let's take the DRM experiment, that when you study the words, if you study them, they activate the associated or the related words. When then these activations spread to other nodes, they will activate words that were actually studied, but they might also activate words that were not studied, which is in this case a spontaneous false memory. The general idea with this is that the stronger the activation between these related concepts, the more chance a false memory or spontaneous false memory will be elicited. There's also a second theory, which is the fuzzy trace theory, which says that there's verbatim and gist traces. Verbatim traces is when you, for example, when you study the DRM words, the font size or the color of the letters that the words were presented in, while the gist traces are the underlying meaning of the DRM theme. And the idea is that, according to the fuzzy trace theory, that when people rely on gist traces to remember what they studied, there are more spontaneous false memories, while if they have a strong verbatim information, they will not. Interestingly, when participants can remember specific verbatim information about external, or in our case, internal misinformation, there's more chance that they will provide or have more false memories for this information. So, for example, in the forced confabulation effect. Anyways, our question was, does this forced confabulation effect actually increase spontaneous false memories? And that was our hypothesis, which we thought that this will indeed increase the associated activation between these concepts, and therefore more spontaneous false memories will be elicited. To study this, we created a new paradigm wherein we combined two paradigms, mainly the DRM, as I have explained before, and the Amsterdam short-term memory task. We combined these because the Amsterdam short-term memory task procedure allowed us to make people lie about words in the DRM list. And I will show you how we did that. So in our study, we had this procedure. Participants came to the lab, and then during the encoding phase were told, you have to read these words one by one out loud. So they had to read symphony, sound, piano, radio, sing, orchestra. After they read the words out loud, they got a simple mathematical task, just as is done in the Amsterdam short-term memory task. And then they got a recognition task. And in this recognition task, all participants were told, please tell us which words you previously read out loud. Then we had a forced confabulation group, and we instructed them, please also lie or fabricate that you read 2 additional words out loud. You can freely choose which ones these are, but to remain credible to the experimenter, try to make them to be about related words to the ones that you read out loud. They did this procedure 10 times for 10 different DRM lists. Then they got a Tetris game just as a distractor task. And then they received a final recognition task wherein we asked them about items that they truly read out loud, words that were, let's say, the critical lures of the DRM, but also the ones that they lied about. And then we wanted to see, did participants that were forced to confabulate have more spontaneous false memories or not? We also asked them about the belief and recollection scores they had for each word. So how much did they believe that they read that word out loud, or how do they actually have a recollection for it? And I'll explain in a second why that was of importance. First, the results. We first checked, did we actually observe a forced confabulation effect? That is, in the studies that usually or typically studied this phenomenon, they used a video and then an interview, and there was some time in between. So we wanted to see, can we actually replicate this effect? And we actually were able to find a forced confabulation effect. So when we asked participants, do you remember reading the word that they fabricated out loud? Participants in the forced confabulation group were more likely to endorse these items than participants in the honest group. However, when we looked at spontaneous false memories, we didn't find any effect. It seemed to be that there was no, or that participants in the forced confabulation group did not elicit more spontaneous false memories than participants in the honest group. So this shows that even though we did find a spontaneous or a forced confabulation effect, this did not seem to stimulate the associative activation between these, which was in contrast to our hypothesis. And now I come back to why the belief in occurrence and recollection scores were important, because one of the explanations we had for these results was that mainly the forced confabulated items did not increase the activation as much as, for example, words that were truly read out loud. That means that maybe the activation was not strong enough to elicit differences in spontaneous false memory formation. And this is what we somewhat see. We see indeed that for true memory items, or that items that they truly read out loud, the belief in occurrence was higher, and same for the recollection scores. So this could be an explanation that there was simply not enough activation. And one way to circumvent this would be to increase the amount of words that they would have to read out loud to see if that truly makes a difference. Another possible explanation is that because the participants had to read the words out loud, which was in line with the Amsterdam short-term memory task or procedure, it could have served as a distinctiveness heuristic. So participants were able to say, well, actually, I read this word out loud because I remember reading it out loud. So it helped them to distinguish between them, which has been shown to indeed help or reduce the amount of spontaneous false memories that are elicited. Lastly, it is also possible that, which is actually in line with the fuzzy trace, that as we found, which is unfortunately not in this slide, I see, that the true memory scores were quite high and there were no differences between the two groups. So it is possible that the verbatim information was quite strong, leading them to easily reject spontaneous false memories. But since the verbatim information was also quite strong for the forced confabulated items, we still do see the forced confabulation effect. And that is what, that's why our results are more in line with the fuzzy trace theory. That was my presentation. I don't know if I will share it, but the article is freely online, open access, open data. And I would love to hear questions if you have any.
Thank you very much.